In our intuition, time is an independent, abstract concept that flows steadily in one direction, from the past to the future. But have you ever wondered why this is the case? Why can time only move forward and not backward? Why can we only remember the past and not the future? Are we existing within time, or does time exist within us? Today, on Enjoy Audiobook, we're diving into the book The Order of Time, which will take us on a journey to explore the essence of time and challenge our conventional views on it. The author of this book, Carlo Rovelli, is an Italian physicist and one of the pioneers of loop quantum gravity theory, often hailed as the next Stephen Hawking. The Order of Time is Rovelli's latest work and has been recognized by Time magazine as one of the top 10 non-fiction books of 2018 and was also one of the most followed books on Daubon in 2019. In the Marvel movie Doctor Strange, Benedict Cumberbatch, who plays the titular character, even recorded an audiobook version of this work, which won the British National Book Award. We will dissect this book in 3 parts. First, we will explore the truth about time from both macroscopic and microscopic perspectives. Second, we will step into a world devoid of time to see how everything operates without the guidance of time. Thirdly, we will delve into why, even in a world where time does not exist, we can still genuinely feel its presence. Let's now embark on this journey to uncover the true nature of time, examining it from both macroscopic and microscopic perspectives. First, let's revisit the concept of time and explore its true nature. From a macroscopic viewpoint, our most intuitive feeling about time is its truthfulness. The true nature of time is characterized by 4 features: independence, uniformity, immediacy, and directionality. Recent studies in physics, however, have overturned these traditional views. Let's start with the independence of time. It is commonly believed that time operates independently, with no force able to stop it. This idea originally came from Newton, who thought that time was absolutely independent and did not interact with external objects. Newton based his entire foundation of modern physics on this concept of time. Today, we've come to accept this viewpoint as common sense. However, the idea that time operates independently and is unstoppable was merely Newton's personal belief. It wasn't an intuition that humanity has always possessed. Some philosophers have disagreed with this notion, and a prime example is the ancient Greek philosopher Aristotle. Aristotle, known as one of the earliest thinkers to question what time really is, nearly 20 years before Newton believed that time was a measure of change. In other words, when we talk about time, we're actually referring to changes that occur. For instance, if I say I'm going on a business trip for 3 days, those 3 days refer to the sun completing its cycle in the sky 3 times between my departure and return. It's that simple. So, what happens to time if everything remains unchanged? Aristotle's answer was that time would indeed stop if nothing changed, because time is merely a record of change. If that's the case, why do we still feel the passage of time even when nothing significant seems to be happening around us? This question leads us to ponder the deeper implications of time and our perception of it. Aristotle's perspective offers a stark contrast to Newton's, and it invites us to reflect on our own experiences. How often do we feel time crawling when we're bored, yet it flies when we're engaged in something exciting? This subjective experience of time challenges the notion of its absolute independence and suggests that our interaction with the world around us might influence our perception of time. In The Order of Time, Ravelli encourages us to think beyond these traditional boundaries and explore how recent scientific discoveries continue to reshape our understanding of time. As we delve deeper into the book, we'll uncover more about how time is intertwined with the universe fabric and our place within it. Stay tuned as we continue this fascinating exploration on Enjoy Audiobook. Why then can we still feel the passage of time in the silent stillness of a dark night, even when we lie motionless with our eyes closed? It's because your heart is still beating and your thoughts are changing. Thus, you can still sense the passage of time. This idea that time must be attached to change to exist starkly contrasts with Newton's views. Opposing Newton was also the contemporary German mathematician Gottfried Wilhelm Leibniz. He believed that time could not exist independently. Behind time, according to Leibniz, lies a more fundamental concept, causality. For example, consider a beer on the table. Hidden within this simple scenario are numerous causal relationships. If the beer bottle isn't opened, the beer won't pour out. If the beer isn't poured, the glass won't fill up. By understanding these causal relationships, we can comprehend the sequence of time. In Leibniz's view, time is like a series of dominoes, each representing a causal link. The fall of the first domino affects the second, and the second affects the third, and so on. As these dominoes topple, we perceive the transmission of causality, and within this transmission, we experience the passage of time. Leibniz was so committed to this perspective on time that it's said his name originally included the letter T, a nod to his deep engagement with the concept of time. This anecdote, whether true or not, underscores the profound impact that the debate over the nature of time had on these great thinkers. As we explore these contrasting views between Newton and Leibniz in The Order of Time, it's fascinating to see how our understanding of time is not just a scientific issue but also a philosophical one. This blend of science and philosophy in the book makes it a compelling read, inviting us to question and perhaps redefine our own perceptions of time. Stay tuned as we continue to unravel these intriguing ideas here on Enjoy Audiobook. In the realm of physics, the letter T represents time. Leibniz firmly believed that Newton's concept of absolute time, represented by T, did not exist. To align with his beliefs, he even symbolically included the letter T in his own name, signifying his challenge to Newton's framework where T stands for time. This anecdote about Leibniz ordering his name to include a T might seem like a small detail, but it highlights the depth of his commitment to his views on time. It's a fascinating reflection of how personal beliefs and scientific theories can intertwine, influencing not just the world of academia but also personal identities. Now, let's shift our focus to a modern scientific principle that indirectly supports Leibniz's skepticism of absolute time, the theory of special relativity proposed by Albert Einstein. According to this theory, surpassing the speed of light is not permitted. This restriction upholds Leibniz's perspective in a roundabout way. Why, imagine if someone could send you a message faster than the speed of light. You would receive the message before you even saw them take out their phone. This scenario would create a paradox where cause and effect are reversed. Allowing faster-than-light phenomena will lead to absurd situations where you could see a glass shatter before it hits the ground or a person die before the trigger is pulled. It's precisely because of such potential absurdities that Einstein's theory of special relativity asserts the constancy of the speed of light, thereby preserving the integrity of causality in our universe. As we delve deeper into the order of time, it becomes clear that our understanding of time is not only a reflection of scientific progress but also a profound philosophical inquiry. The interplay between science and philosophy in this book not only enriches our knowledge but also challenges us to rethink our perceptions of time. Keep tuning in as we continue to explore these captivating concepts here on Enjoy Audiobook. This principle ensures that all causal relationships in the world do not occur in reverse, thus indirectly supporting Leibniz's view of time. Moving on, Einstein introduced a new concept of space-time. As we discussed earlier, the constancy of the speed of light and the vastness of the universe mean that light takes time to travel from one place to another. The greater the distance, the longer the time difference. Therefore, time and space are closely linked and inseparable. A very intuitive example of this is the light year, a unit of distance that uses a time concept, implying that time and space are indivisible. We unify them into a single entity called space-time. Einstein not only merged time and space but also integrated gravity. For instance, the Earth's orbit around the Sun is actually due to the Sun's massive mass warping the space around it, and the Earth simply slides along this curved space. This curvature of space plays the role of a gravitational field, and since space and time are two sides of the same coin, space-time is essentially the gravitational field. In this way, space-time is a physical entity just like the gravitational field and the electromagnetic field. Although these fields are not tangible to us, they are not detached from the physical world. Therefore, the field and the changes in things are interconnected and dynamic. To draw an analogy, in Newton's view, time is like a stage where the universe's life unfolds. In contrast, Einstein's space-time is not just a passive backdrop but an active participant in the cosmic dance, influencing and being influenced by the matter within it. As we continue to explore the order of time, we see how Einstein's revolutionary ideas further complicate and enrich our understanding of time. This blending of time, space, and gravity into a single dynamic entity challenges us to rethink not just the nature of time, but the very fabric of reality. Keep tuning in as we delve deeper into these profound concepts here on Enjoy Audiobook. In Einstein's view of time, the stage of time is not static but actively participates in the performance alongside the actors. This dynamic interaction between the stage and the performers leads to the breakdown of the absolute independence of time. So, how exactly does this stage of time perform? This brings us to the second characteristic of time uniformity. Commonly, people believe that time is uniform, meaning it treats everyone equally and flows consistently and smoothly for everyone around the world. However, the reality is quite the opposite. Time is inherently unfair. It speeds up and slows down. Two key factors influence the pace of time: mass and velocity. Let's talk about mass first. An object's mass can slow down time in its vicinity. The greater the mass, the more noticeable the slowdown. This is because a massive object's gravity can warp the space-time around it. The greater the mass, the more severe the warping. For example, Earth is a massive object, and time passes slower the closer you are to the center of the Earth. Therefore, people living in plains age slightly slower than those living on mountaintops, even if the altitude difference is just a few centimeters. This fascinating effect means that the cells in your feet are aging slower than the cells in your head. Now, let's discuss velocity. Motion also causes time to slow down. Time on a high-speed train, for example, moves slower than time for someone stationary. This aspect of time dilation is another mind-bending concept that challenges our everyday experience of time. As we continue to delve into the order of time, we see how these concepts not only deepen our understanding of time but also challenge us to reconsider the very nature of reality. Stay tuned as we explore more of these intriguing ideas here on Enjoy Audiobook. Why does time slow down the faster you go? Let's consider an experiment to understand this phenomenon. Imagine a photon clock, a simple device consisting of two mirrors facing each other with a photon bouncing vertically between them. On the ground, if the mirrors are 1 meter apart, it takes the photon nearly 150 million bounces to count as 1 second. Now, let's place this photon clock on a high-speed spaceship. To someone on the spaceship, the photon still appears to be moving vertically. However, from your perspective outside the spaceship, the situation looks quite different. The photon is still moving vertically, but since the spaceship is also moving forward, the combined motion results in the photon traveling in a diagonal path. In other words, from your viewpoint, the photon's path elongates. Since the speed of light is constant, if the path lengthens, it takes longer for the photon to complete one round trip. Therefore, time, as observed from your perspective, slows down on the spaceship. Everything appears to be in slow motion. A sneeze that takes only a second on the spaceship might seem to take a minute from your viewpoint. Now we understand that both mass and velocity can alter the flow of time. As we continue to explore the order of time, these insights not only deepen our understanding of time, but also challenge us to reconsider the very nature of reality. Stay tuned as we explore more of these intriguing ideas here on Enjoy Audiobook. In this exploration of time's flow, people at different altitudes or on various modes of transportation experience time differently. So, which time is the real time? The book points out that there are many versions of time, and none is more real than another. This challenges the second characteristic of time uniformity. If two people experience time differently, how can they communicate or interact effectively? Let's now look at the third characteristic of time: immediacy. A key concept here is the idea of now. If you want to know what a family member in another room is doing right now, you simply look at them. However, it's important to know that you're seeing them through the light that travels from them to your eyes, which takes time, albeit a fraction of a second. So, you're not actually seeing where they are or what they're doing right now, but rather what they were doing a fraction of a second ago. Normally, we disregard such brief intervals, but imagine if your family member lived on a planet 4 light years away. You would only see what they were doing 4 years ago, not what they are doing now. You might think, well, seeing what they're doing 4 years later means I'm seeing what they're doing now, right? But that's not quite accurate. This highlights the complexity of understanding now across different distances and challenges our perception of immediacy in time. As we continue to delve into the order of time, these insights not only deepen our understanding of time, but also challenge us to reconsider the very nature of reality. Stay tuned as we explore more of these intriguing ideas here on Enjoy Audiobook. It doesn't work. As we discussed earlier, time in the universe lacks uniformity. Although 4 years may have passed on Earth, it might have been 10 or even 15 years on the planet Bilin. Moreover, asking which moment on Bilin corresponds to a specific moment on Earth is as meaningless as asking which basketball team won the championship or who was elected President of the United States. There is no single moment on Bilin that corresponds to the present moment on Earth. In fact, there is no unified time throughout the entire universe. The concept of time can only be local. The concept of now that we use on Earth is like a bubble surrounding us, always representing the present moment as we perceive it. This bubble does not extend to the entire universe. So, how far can this bubble extend? It depends on how precisely we define time. The higher the precision, the smaller the bubble, and the narrower the range that the concept of now covers. If we define now in nanoseconds, it only spans a few meters. If we define it in milliseconds, it spans thousands of kilometers. Because humans find it difficult to discern differences of fractions of a second, we consider the entire Earth as one bubble. Thus, our definition of now is a vague description based on our own definitions and perceptions. It's like seeing a rainbow that appears to touch the forest at a specific point from a distance. As we continue to delve into the order of time, these insights not only deepen our understanding of time, but also challenge us to reconsider the very nature of reality. Stay tuned as we explore more of these intriguing ideas here on Enjoy Audiobook. As we delve deeper into the order of time, we encounter a profound realization that challenges our everyday understanding of time. When we attempt to pinpoint the exact moment where a rainbow seems to touch the forest, we find that such a point doesn't actually exist. In our daily lives, the most impactful characteristic of time isn't its independence, uniformity, or immediacy, but rather its directionality. For centuries, countless individuals have lamented that time is cruel and relentless, always moving forward and never backward. Why does time distinguish between the past and the future? This question has been a central topic in physics throughout the 19th and 20th centuries. Although it feels natural to us that time flows from the past to the future, finding a law or equation in physics that differentiates the past from the future is nearly an impossible task. Whether it's Newtonian mechanics, Maxwell's electromagnetism, Einstein's theory of relativity, or Heisenberg and Schrödinger's quantum mechanics, all these equations describe physical phenomena that are reversible. That is, if an event can occur in a forward direction, these theories also allow for it to occur in reverse. For example, with a planet, you can calculate its future position and velocity, and you can also reverse these calculations to determine its past position and velocity. Since both forward and reverse directions are possible, what basis do we have to say that one direction is the past and the other the future? The only irreversible law in physics is the second law of thermodynamics, which states that heat can only flow from a hotter body to a colder one, and not the other way around. This is the only principle in physics that introduces an irreversible element. As we continue to explore the order of time, these insights not only deepen our understanding of time, but also challenge us to reconsider the very nature of reality. Stay tuned as we explore more of these intriguing ideas here on Enjoy Audiobook. The second law of thermodynamics, a one-way, irreversible law, closely ties the directionality of heat with the directionality of time. Every event that differentiates the past from the future involves heat. For instance, when a stone falls to the ground, mechanical energy is converted into thermal energy, slightly heating the stone and the ground. The heat dissipates and the stone stops moving. Without the involvement of heat, due to the law of conservation of energy, the stone would keep bouncing indefinitely and never come to a stop. Aging occurs because our bodies generate heat, bicycles wear out due to the heat generated by friction, and even thinking heats up our brains. Whenever you observe a phenomenon where time passes, heat is involved. Heat is the only physical variable related to irreversible phenomena, and it also plays the role of time. So, how does heat differentiate the past from the future? If the universe initially existed in a state of thermal equilibrium, where temperatures were equal everywhere, there would be no change and thus no flow of time. This leads us to a profound realization that the answer to this question lies within ourselves. Our observation of the world is inherently blurry and incomplete. To illustrate, imagine a deck of cards where the first 26 are red and the last 26 are black. We perceive this deck as arranged in a sequence known as ordered. Now, let's shuffle the deck. After shuffling, if the sequence of suits happens to be clubs, diamonds, spades, and hearts, isn't this another form of order? We find that when we observe all the details, every sequence of cards is unique and can be considered ordered. Similarly, when we look at the universe, it's like a giant deck of cards, and our planet is just a speck of dust within it, interacting only with a tiny fraction of the universe. Therefore, we can't see all the possible combinations of this cosmic deck of cards. We only perceive a small part, like a blind person feeling an elephant, and ignore most of it. Then, we assume that time must flow from the past to the future while feeling the flow of time. But what if we consider all the details of the universe? Would any sequence of events be considered more ordered or special? The answer is definitely no. Time's flow might not necessarily be a characteristic of the universe, but rather a unique perspective from us humans. So, in the macroscopic world, time lacks independence, uniformity, immediacy, and directionality. The time we're familiar with has become completely unrecognizable. In the microscopic quantum world, the continuity and certainty of time that people generally believe in are also overturned. Earlier, we discussed how space-time is a gravitational field, a physical entity. In the microscopic world, this physical entity exhibits quantum characteristics, and time is no exception. One of the most fundamental characteristics of quantum mechanics is called quantization, which means that energy does not change continuously but can only take specific values. What happens when time is quantized? If we use the most precise clocks to measure an extremely small period of time, we will find that the measured time can only be in discrete segments, jumping from one value to another, just like algebra. The continuity of time disappears. Moreover, there's something even stranger in the quantum world. Quantum mechanics has an effect called the uncertainty principle, where particles exist in a state of superposition, and no one can determine their exact position. You might have heard of Schrödinger's cat, a famous thought experiment about quantum superposition. It involves placing a cat in a sealed box with a small amount of radioactive substance and a vial of poison. There's a probability that the radioactive substance will decay, triggering a mechanism that breaks the vial and kills the cat. If the substance doesn't decay, the cat survives. According to quantum mechanics, because of the superposition, the cat is simultaneously alive and dead until someone opens the box to observe it. As we continue to delve into the order of time, these insights not only deepen our understanding of time, but also challenge us to reconsider the very nature of reality. Stay tuned as we explore more of these intriguing ideas here on Enjoy Audiobook. In the quantum world, the radioactive substance in Schrödinger's cat experiment exists in a superposition of both decaying and not decaying states. Consequently, the cat is also in a superposition of being both dead and alive. This is the famous Schrödinger's cat. This cat, simultaneously dead and alive, exemplifies the concept of superposition. When time itself is in a superposition state, a single moment can exist simultaneously in both the past and the future. It's hard to imagine, but this is how the quantum world operates. Now, having analyzed both the macroscopic and microscopic worlds, we see how time has lost a series of characteristics, making the time we are familiar with almost unrecognizable. In a world without time, how would everything function without the guidance of time? Let's move on to the second part of our discussion to see how a world devoid of time would operate. In 1967, two American physicists discovered a fundamental equation of quantum gravity that astonishingly did not include the variable of time. Initially, no one could understand this equation, not even its discoverers. Without time, could the world be static and unchanging? However, the absence of time in this fundamental equation does not mean that time stands still. On the contrary, it implies that change is ubiquitous and does not need to be directed by time. It describes not how things change over time, but how things change relative to each other. As we continue to delve into the order of time, these insights not only deepen our understanding of time, but also challenge us to reconsider the very nature of reality. Stay tuned as we explore more of these intriguing ideas here on Enjoy Audiobook. To illustrate how things change relative to each other, let's consider an example that you'll find quite enlightening. Galileo discovered that he could use the beating of his pulse to measure the time it took for a chandelier to swing back and forth. Following this discovery, people realized that since the swinging time of the chandelier was consistent, they could invent the pendulum clock. Subsequently, doctors could use the pendulum to measure a patient's pulse. Have you noticed the circular nature of this? Galileo used his pulse to measure the pendulum, and doctors used the pendulum to measure the pulse. In reality, time is just a boundary. We've never actually measured time itself. What we've measured are just two physical quantities, the pulse and the pendulum. Then, we derive how these quantities change relative to each other. The so-called time is like the auxiliary lines we use in geometry. Though they don't exist, they help us solve problems. If we can find variables that synchronize with each other, like the pendulum and the pulse, we can use their mutual changes to represent time. There's no need to single out one of these variables and label it as time. When we abandon the concept of time, there's one thing that becomes clear: the universe is composed of changing time. Previously, we believed that the universe was made up of objects, but in reality, all objects are just manifestations of changing time. For example, a stone is not merely an object, it is a complex vibration of quantum fields. A cloud is not just an object, it is the condensation of water vapor in the air. A family is not an object but a collection of relationships, events, and emotions. Similarly, a person is not an object, they are a complex process involving the constant exchange of matter, information, and language. In this universe composed of changing time, everything can play the role of time. This is the true way our world operates. But here comes the question: if this world is devoid of time, why do we still genuinely feel its presence? Where does it come from? Why does time exist? Let's now delve into the third part of our discussion: the origin of time. Time originates from our memory. As mentioned earlier, it is heat that plays the role of time. This leads to an important in a state of confusion. This result is that traces are left behind. For instance, when we write, the friction of the pen slightly heats the paper, leaving behind marks. We judge time by these traces. Traces signify the past, and the absence of traces, the future. In a world without heat, no traces would be left on paper, and we would be unable to determine time. Our brains collect these traces from the past and form memories. Moreover, the brain can combine scattered memories to predict the future. For example, when someone throws something at you, your hand cleverly moves to where the object will be to catch it. This judgment is made based on past impressions. The brain also tells us that planting seeds will yield crops and going out in the rain will get us wet. When we see a cup falling and shattering on the ground, it doesn't produce three distinct signals. Instead, it generates a single signal. We perceive the entire process of the world happening, not isolated moments. It's like listening to music. We hear the combination of notes, not each note independently. If the brain couldn't connect these events sequentially, how could we hear the beautiful music at this very moment? Time is a coherent sensation that our brains create. This idea is actually quite ancient. The Roman philosopher Augustine, in his Confessions, questioned the nature of time, asking what it is that we measure when we measure time. He suggested that time exists within our minds, a concept that German philosophers Kant and Heidegger also shared. They believed that time exists only within the human domain, shaped by our internal perceptions. The writer Marcel Proust had an even clearer vision. In the first volume of In Search of Lost Time, he wrote that reality is constructed by memory. Now, we finally uncovered the true nature of time. To summarize, the 6 commonly accepted characteristics of time are all non-existent. First, time does not exist independently. It is tied to the flow and method of time itself. Second, the speed of time can be altered by mass and velocity, affecting people at different altitudes or on different modes of transportation. As we continue to delve into the order of time, these insights not only deepen our understanding of time, but also challenge us to reconsider the very nature of reality. Stay tuned as we explore more of these intriguing ideas here on Enjoy Audiobook. In our exploration of time, we've seen that people on different modes of transportation or at different altitudes experience time differently. This leads us to the third characteristic of time: immediacy. What we consider now might be the past or even the future for someone else. The fourth characteristic is the flow of time from past to future, which may just be a unique human perspective. Fifth, time is no longer continuous. Sixth, in the quantum world, time also loses its certainty. An event can exist simultaneously in both the past and the future. We then enter a world where time does not exist, discovering that all objects in the universe, such as clouds or stones, are merely manifestations of changing time. Finally, we explored the essence of memory, which is a continuous sensation created by us. In 1955, Einstein said something intriguing during a conversation about interesting facts. He stated, "He has departed from this world a step ahead of me, but that's trivial." For those of us who believe in physics, the distinction between past, present, and future is nothing but a persistent illusion. This statement wasn't just an academic discussion about time, it was a reflection of Einstein's life experience. Time exists because we are the creators of time. Today, as we continue to delve into the order of time, these insights not only deepen our understanding of time but also challenge us to reconsider the very nature of reality. Stay tuned as we explore more of these intriguing ideas here on Enjoy Audiobook.